And it is time. So, get ready for next slide. So let's get started. This is part 2 of the LAMP session at IETF 120. This is the note well. It is a reminder of the things that we agreed to follow as participants in the IETF, covers behavior and the standards process and anti-harassment and copyright issues and patent issues. Please do not contribute if you're not familiar with this. Next slide. Please live the IETF Code of Conduct. Do not harass each other. Treat each other with respect. And basically, it's okay to attack a bad idea, but don't attack the person delivering it. Next slide. Please join the Medico. It makes the blue sheets and tells us who's here. It also is the way that we will manage the queue for speaking at the mic, which makes sure that the people in the room and the people remote have equal access to the mic. If you're a remote participant, please mute your audio and your video unless you're at the mic line or at the front of the mic line. And a headset actually makes the experience far better. Next slide. We agenda bashed in the first session. We're now, I believe, on page 4 of the agenda. So we will, yes, we are on 4. Back up one, please. Yep. We're on the last item here, item K on composite signatures. We were in the middle of that presentation when we ran out of time. The question is there more to say on this, John?
I couldn't get in.
You couldn't get in?
What's that?
Someone in the hallway behind us screamed, "I can't get in."
Yeah, so if you were here for the last one, so I did finish the slides.
Okay.
I don't know if there was next updates. I don't know, maybe you just want to fast forward to that kind of ending slide. So I kind of went through the editorial changes, outstanding issues, talked about the success at the hackathon. We have 4 implementations. Just would like to see if people had some comments on kind of next direction, other than, obviously we're going to do the changes that in the previous slide that I talked about. Anything else that we should be looking at? I guess one thing I can point out, the question that came up about using like the RSA 4096, talking with some people today, and one of the things that could mitigate this issue is just not to lock down on the size of the RSA modulus, just like what is done, with the regular RSA signatures today. If we did that, then people could decide if they want to use RSA 4096 or 15360 or whatever crazy size they want to use. You could figure that out just by the size of the modulus, right? So that it wouldn't have to be specified. And if we did that, then that might solve us having to make new OIDs for all these various sizes of RSA. So that's just some discussions. I don't know if people have comments on that. Any comments on anything?
Mike's in the queue.
Okay.
Yeah, I mean,
oh, you're blasting us, man.
all right. I'll talk much louder. Is that better?
Much.
I haven't changed. All right. Yeah, I would be shocked if there was no discussion on composites for the first time in history. So there was good discussion. So in addition to what John said, there was also good discussion on list, largely led by Peter and Sophie, about suggestions for cutting down the size of the list. Remove the MLChem 512s, maybe remove one of the RSA strengths. I don't know if any of that wants to be said out loud.
I mean, we're open to cutting down the list, right? Like,
Yeah.
I don't think having 13.
Some of those people are in the room, but not
So-
coming to the mic. So, oh, there we go.
I suppose we're talking about 6 here,
That's-
not chems, sorry. So it would be,
He's on it.
it would be MLDSA 2 would be the lowest candidate to chop.
Right.
Yes, I'm Sophie. Need to figure out where the hand raise thing is. My main argument for like cutting down the size of the list, and I think Scott also wrote an email in agreement, is that we actually try to accomplish different things with the different parts of the hybrid. And that gives us the opportunity of like actually doing exactly that and not having like every single combination that that we want, but like using each side of the hybrids to accomplish a specific goal. For the classic side, this is mostly defense against any problems with the PQ side. From a security perspective, that means that X25519 or anything else has this accomplishes this. Since you're going to break RSA 2048 at the same time that you break RSA 4096 and everything else with a quantum computer. So from a security perspective, we really do not care what goes on the classical side. From a compliance perspective or from an implementation existing perspective, it's a bit different. But yeah, from a security perspective, we don't care there. On the PQ side, on the other hand, the thing that we're trying to defend against with a hybrid is like weaknesses in implementations, potential new attacks, and so on. So I do think that it makes some amount of sense to be like taking the somewhat more conservative MLChem 768. For signatures, I'm a lot less decided whether MLDSA 44 or 65 is a like better choice, but also less urgent there. So my approach to cutting down the list is like looking at each side separately and then taking only the combination where it like actually accomplishes a coherent goal that someone is asking for, which means that basically the classic side is only constrained by compliance, and the PQ side, I wish that we can all use just one size of MLChem, but that is a different discussion, unfortunately.
Yes.
Not gonna happen. Quinn? No, he's an author, so he's helping present.
Quỳnh Đăng Agnes. This is our security recommendation for the NIST from NIST policy perspective. We would like people to use level 5 security everywhere. And if somehow a user thinks that he or she does not need that level 5 and wants better performance, then they can go to level 3. And then if they think that they don't need level 3 security and they want better performance, then they go to level 1. And also at the same time, that's why we would like to have level 1 and 3 and 5 available to users. But does that mean we want people to use level 1? But we hope them to be available for the users. It could be some cases that people go for level 1. But again, we recommended level 5 first, and then level 3 and level 1.
Okay, so we have level 1, 3, and 5 for MLDSA. So I guess the question is, what is the classic algorithms that pair with them, right? So that's
Tim, could you go back a few slides? We do have the list in this deck.
go to the list of the 13 of them.
For the MLDSA, we don't have level 1, we have level 2.
Oh yeah, sorry.
So
that's
the
right.
only
It's level
MLChem
2,
is we have level 1, 3, and 5.
Yeah, so.
And for the MLChem, I think that's what we talked about as well, even though it's not in the draft. Right now, I'm really recommended go with 2 curves, which are widely used or maybe widely available than the curve P521. So that's why we specified 256 and 384.
There is no 521 in this list, you'll notice.
No, I'm talking about the MLDSA and MLChem and the
Yes, yes.
hybrid gear change.
I think we still have 521 in the chem side, yeah, but we can change that to match.
Yeah, so I don't know if that comment helps us reduce the size of our list, but it's good to know. Yes.
One other thing worth mentioning is we've had a request from a real implementer who I unfortunately can't name publicly yet, even though asking a lot, to have an RSA 4096 combination because their policy requires 4096 and they can't backtrack their policy on the classical side. So there's a question to the working group: do we add two 4096s, PSS and PKCS1, or do we just replace the 3072s?
Or the other option, which I mentioned earlier, is we don't specify the RSA modulus size.
Or we go back.
And then that would actually solve that problem and reduce the number of OH needed.
Yeah.
But I think we've had support raised by a number of people for leaving the modulus size fixed. I vote in that camp also.
Yeah. That was actually the one that I wanted to talk about, because that's a point that I'm still kind of thinking about, and so I'm still sort of scratching my head a little bit. One of the things I am worried about on that one is if we do go in the direction of just having the RSA modulus, I'm a little bit worried from a complexity point of view that it's easy to do when there's one key, but now that there's two keys, and for composite we don't have a boundary between them, and so looking inside the key for the size is a little bit more challenging for composite than it is for a single signature, but it's probably feasible. So just keep an eye on whether that's a little bit more complicated to implement or not. RSA is also an interesting use case. I really like what Sophie was saying about keeping an eye on what we're using these for. And in particular, remember the previous discussion, we would consider dropping RSA entirely if it wasn't for the fact that there are some people who have deployed infrastructure that can do RSA but not ECC, and forcing them to change just so that their fallback is ECC instead of RSA seems a little bit of a bridge too far. So even the use of RSA is sort of a backup for backwards compatibility people anyway. So us being extremely strict about the size of your backwards compatible RSA key, that strikes me as security engineers maybe causing problems instead of fixing them.
+1.
So go ahead, Scott.
Can I also add one more comment on top of John?
Sure.
I'm not convinced that dropping the modulus size actually saves anything. You still need OIDs for PSS versus P1, and you still need OIDs for RSA with MLDSA 44 and RSA with MLDSA 65. So I'm not sure you actually save anything by doing that.
You do, but you only need 6 instead of possibly 10 or 12 or whatever layer of RSA someone might decide they need. I'm just saying that's an option. I mean, there were some discussions on that. We don't have to do that, right? They both will work.
Okay, couple of comments. One is a +1 to Sophie's comments, which I've already said on the mailing list. Next question to Quinn. You said that NIST is going to recommend around level 5 for everything. To what extent is that going to be a normative, or is that going to be sort of a advisement?
And is it compatible with CNSA?
Quinn Dang, and this again. That has been our policy, always been that way. It's not that we don't require level 5, which is recommendable to use the most secure option first. And even in the draft FIPS right now, if you look into the draft FIPS 203, you would find that language at the almost at the end of the FIPS when we say, use level 5, and we kind of like making the level 3 as default because it's the best balance between. I think it's the good trade-off for performance and security. But that language was not superly perfect. But what we meant was that use level 5, and then if you want better performance, you go level 3, and if not, you go to level 1. If you're okay with level 1 and get more performance. The same with AES. We're okay with AES 128, but we prefer to use AES 256 over AES 128.
Okay, I would make the observation that for certificates, ML Chem 70, the level 5 is considerably more expensive, and so quite frankly, I don't know if it's actually just the expense is justified in that case. Thank you.
Sophie?
Yes, I wanted to mostly say my opinion on the RSA key size bit, which I think is something where Scott and I differ in opinion. Mostly just because of the symmetry, making it prettier. I prefer the RSA key size in there because everything else has its key size as well. From a more like security and not beauty point of view, the idea is that you should fully specify your algorithm, and the modulus size is part of your algorithm. It's not the same algorithm if the modulus size is different. Of course, with RSA, that is like actually somewhat of a debate that you can have. I don't have strong feelings about this. I think it makes sense to have the modular size in there, but it's not not the worst thing to get rid of it. And I think the brain pool curves we can just get rid of. It sounds like.
Well, we would, if people don't need them, we will get rid of them, but we have heard from European places that they like brain pool curves. So if we can, I guess, get confirmation that that's not the case, then yes, we can remove them. I guess the other thing to think about is I know like the Open PGP group is also doing composites, right? And probably aligning with them in some way makes sense. And I know I think they have brain pool curves as well. So that's something to think about too.
So I will make one observation, and that is when we just use RSA signatures as today, we have OIDs for RSA with hash X. And it says nothing about the modulus size, which has led to things like RSA 4096 with SHA-1.
Yeah.
And having an impedance match there makes a lot of sense to me.
Okay. Yeah. So it sounds like we're leaning towards the direction of at least assigning new OIDs for the RSA 4096 one then. And the brain pool ones, I guess we need to talk to people and see if we actually need them, or maybe there's only one or something that we can get down to. So does that seem to be what people are coming to agree on? That's my read of the room.
Okay.
Yeah, particularly on the brain pool thing, let's take it to the list because it's a Friday and there's not a lot of people in the room.
Okay, thanks.
Yeah, it'd be nice to have somebody speak in favor of, as opposed to you speaking to the authors in favor of. Thank you.
So yeah,
All right.
that's everything. Thanks.
All right, thanks. Okay, so let's go back to the agenda. I believe we're now entering the SMIME documents. The first one is CMS Kyber. There he is.
Microphone's okay this time?
Yes, much better, or at least the way you're holding it.
Yep. Okay, this should also be a quick one, just an update on the CMS Kyber draft on behalf of my co-authors. Next slide, please. So update since last time in 119, it was discussed having both HKDF and KMAC as you must implement one or both, I suppose, of these, and with justification for both. So I added that text. If people are going to disagree with that, we can do that here. I also addressed Jonathan Hamill's review, basically simplifying some text, doing a bit of moving around and removing some, I guess, unnecessary description that's already handled in the CMS Camry draft, and added ASN1. Next steps are to wait for NIST, add some examples, harmonize with the Kyber certs draft, and we can talk a little bit about whether to include public key and ciphertext in the KDF. That'll be on the next slide. It might not be necessary, but if Scott has a comment first, we can go to him.
My comment is as having the two optional mandatory to implements. The whole reason you have a mandatory to implement is interoperability. If you have an implementation which does only HKDF and then one other one which does KMAC, only does KMAC, both are compliant, but they can't interoperate. My opinion is pick one, make that a mandatory to implement, and call it a day. And I don't care which one. I don't have a dog in this fight.
Okay. And I agree that it would be much nicer to have a single one. If I recall some time ago, Scott, you were actually the one who suggested that we use KMAC because it lines up with what happens internally with the ML Chem. I'm quite happy to drop KMAC entirely because it seems like people are more keen on having HKDF with SHA just because SHA-2 is much more widely implemented. Mike? Not Mike?
Yeah,
Mike?
I was. You just answered it. I was going to ask if HKDF means SHA-2. Good, thank you.
Yeah, sorry, it's HKDF with SHA-2, depending on the level, SHA-2 256 or SHA-2 512, depending on whether it's being paired with whichever level of ML DSA. So I'm certainly happy to, for the, I don't know, second or third or fourth time, change the KDF in the document and remove KMAC entirely and just lock it down to HKDF with SHA-256 or SHA-512. Yeah. Next slide, please.
Next slide.
So Mike just said I would leave HKDF SHA-2 as optional. Isn't everything? Maybe Mike, you can come back on and explain that.
Didn't your last slide have the letters MTI on it?
Something has to be MTI.
Now, what I think he's saying is leave it in the document as specified, but not mandatory to implement.
Okay, so to be specific, something has to be mandatory to implement, right? So which one should be and which one should be optional?
I think that Mike and Scott are disagreeing about which one should be mandatory.
Oh, fair. Maybe that's right. Okay, I retract.
Okay, so I think what this means is, well, okay, maybe Quinn has a comment first. Quinn?
He's going to the mic.
Okay.
Quinn Yang, if I look at the two proposals and one is NIST compliance and the other one is not, then I would go with the one in compliance.
This compliant.
Because I don't know, right now we just say use KMAC or use HKDF. Without details, I can't know which one is compliant, which one is not.
Are they not both compliant?
I'm sorry. I thought you asking which one people would prefer, right?
Yes.
And that is from my perspective. If one is NIST compliance, the other one is not, then I would prefer the one is compliant with NIST specification.
Okay.
Yeah.
I'm saying I believe that they're both compliant. So.
But at the same time, I be here. I will help to make sure the one is the one we would specify to be compliant with NIST. So we shouldn't be worried about that. We should worry about what primitive has better security properties and what primitive would better for people to use. Yeah, that would be the question on the KDF.
Okay. Okay, so Sorry.
Oh, because you have the other questions. Do you want me to answer the other questions on the slide, or do you want me to answer them later?
I can present them first, and then you can answer them. unless you're just going to say something and I don't even have to do any work to present it. I don't know, a few weeks or a month ago, Deirdre posted something to the list pointing out the work by Sophie about the Malbind properties and various of chems. And the question was, do we have to add public key or ciphertext to the KDF for CMS? Based on my reading of it and this quote from Sophie, it seems like no. She's also in the room, so maybe she can comment. So yeah, the question is, do we actually need to do anything here or not?
Sophie's going to the mic.
Okay.
Yes. So my last name is spelled differently.
Oh, I'm sorry.
Sorry about yeah. So yeah, this is a long topic. I feel like I'm talking too much here, but how bad is the misbinding thing? Like the backstory here is that Cas Kremers came up with some definitions and left it as an open question of what MLChem actually fulfills. I then found, like by looking at the definition, I found reasons of why MLChem is not fulfilling these very strong Malbind KCT or Malbind KPK properties. That being said, the attack model here is extremely strong. It assumes that the attacker has full control over the private key. And with this full control over the private key, they can create a situation. I'm like, if we have the time, then I can talk about this for quite some time, unfortunately. With this full control, they can create a situation where two parties will agree on the shared secret, but they will not agree on either the ciphertext or the public key. That is most of the time probably not an issue. My main reasoning for that is that if we look at ECIS in the way that it's usually deployed in HPKey and similar, we have not just mal misbinding, but what in Cas's paper is called on misbinding, so honest parties, by just of sort of very similar note of like, I do something that is kind of trivial edge case, slipping by the definition. In the case of ECIS, I changed the sign of the Y coordinate of the like ephemeral public key for the ciphertext, or the public key for misbinding to the public key. And if I haven't hashed in the ephemeral public key or the static public key into my KDF, then that will lead to this misbinding property. Is it a problem in practice? I don't know. It's hard to say. There are sometimes situations where the idea that the attacker has control over the private key doesn't sound as ridiculous as it might on first glance. One example that I can share is a situation that we had where we did a static ECDH key exchange, which provides authentication. But it has this property called KCI, key compromise impersonation, where if I know your private key, I can not only impersonate you, but I can impersonate the other side to you as well. Not a big deal, who cares? Lots of protocols have KCI as a property, so no problem, ship it. At the same time, some other security team had the problem that they needed a one-side authenticated version of this protocol. And so they did something that sounds very reasonable of, well, if I have a password and I share this password with all participants, then I'm no longer authenticated. So instead of doing a self-signed certificate, which requires extra code, they just made a credential that was shared among multiple parties. Which means that that then results in a vulnerability, because now the KCI becomes an actual problem, because now all parties know this private key, and we are actually in the situation where we have a shared private key that is known to the attacker. In this case, it would still not be malbind that would be a problem, but it would be in Casus Papers terms leak bind, where the attacker has access to the private key, but is not able to manipulate it. But you could imagine something where like this shared credential is like, I don't know, stored in a network share or something, just so that everybody has access to it, where the attacker also has write access to the credential, where you would then get this situation where the attacker actually has has this access to the private key, and we're not already completely screwed. So this is like the long motivation of why sometimes it actually matters, even when the attacker has access to the private key as a precondition for this attack. The problem now is that KCI is not the same as misbinding. So even in this hypothetical scenario, I'm not aware of any scenario where the misbinding actually would hurt the protocol. So far, I have not seen any protocol that has been constructed where this malicious misbinding is actually a problem. CAS is somewhat optimistic that there might be such a protocol, at least hypothetically. I think that such a protocol basically needs to be constructed in order to be vulnerable, which probably means it's not a big deal. So yeah, this is my very long rant of like, is this a big deal or not? Probably not, but like, you can certainly imagine a future where someone produces a vulnerability because they expected this binding property to hold, but it actually didn't because of some very strange thing that is implicit in the FO transform and the way that the private key is serialized. Like all these attacks only are based on the forms of serialization of the private key. They all go away if you don't serialize the private key. It's kind of weird edge case, but I don't know. I can't really tell you what it means.
Okay. Informative, but doesn't answer the question.
So, Daniel, regarding your point later on the slide regarding private keys and stored as seed, I think we should focus on transmitted, like in a PKCS8. There, I think it makes sense to require the private key be transmitted as a seed, but what form they store it in the implementation, I don't think is our business.
Fair enough. So that would be an update to this draft, or maybe the Kyber certs draft, or maybe both. We'd have to wait, I suppose, for the NIST publication anyways.
Well, right. But so you can update it at your leisure.
Okay. So, I mean, if we did that and said it had to be transmitted as seed, then it sounds like we wouldn't have to do anything specific in this draft to mix the public key and ciphertext into the KDF.
That seems to be the case.
Okay. In that case, this is it. I'm finished.
All right. Thank you. The next document is the CMS Sphinx Plus. It's been updated to provide, I did not make slides because this is very short. It's been updated to provide some guidance on when you're using it in CMS and you hash the content and you store that hash as a signed attribute, and then you DER encode the signed attributes and you sign that with Sphinx Plus. We've made some recommendations about which hashes have comparable strength to the various Sphinx Plus signature sizes, the 128, F, and S, and so on. So that was the only addition that we've made, is that guidance, and we're waiting for NIST OIDs. Okay. And next is composite chems. This is going to be short, right?
Absolutely not. I'll do my best. I do have a number of slides. Okay, let's just go. The audience is familiar. So we'll start with the changes that we've made this round that break interop. Sorry, I'm distracted by Dan's comment in chat. Okay, so the construction has been totally rewritten. The combiner construction has been totally redone in this draft. Partially, it was to get compliant with NIST SP 856C R2, although with the very recent discussions on list with Quinn, and especially since the OpenPGP session on Monday, I've realized that we don't actually need to do all these changes. So I'll get to that on the next slide. But the weird rearranging here was with the intention of getting compliant. Also happens to align with X-Wing, which is a nice bonus. So here's the currently proposed combiner, although I'm literally about to change it like today. But let's go through what's in the current 04. Next slide. So the first change is the KDF is now SHA-3 of the appropriate SHA-3 size. It is no longer KMAC. That aligns with X-Wing and it aligns with OpenPGP. Next. The counter is this super stupid fixed value. Although as per mail list discussions, Quinn pointed out you actually don't need it. There's a follow-up, I don't know if it's a implementation guidance document or something, but there's a follow-up document, not 56C itself, but a different document that actually allows you to omit this when it is constant and there's only a single iteration. So we'll definitely look at taking this out because it is dumb. Next. We did a little switch here where we put the traditional shared secret first, which is bizarre because everywhere else in the document, the MLChem component comes first. We did this because we believed on sort of a naive reading of 56CR2, it looks like the construction Z prime equals Z concat T. It looks like Z is the thing that you have to get your FIPS compliance from, but in fact, Quinn pointed out there's a sentence buried way lower down that says actually it can be either component that's FIPS certified. So we thought we had to put the thing that we know is FIPS certified first in order to be compliant, but turns out that's not true. It can be the shared secrets, both of them have to come first before all the other crap, but we thought the order of the shared secrets matters. Turns out it doesn't. So I'll reverse this change and keep the ML Chem SS first and the Trat SS second. Good. Next. And then we did some rearranging here. Initially we had it like shared secret 1, ciphertext 1, shared secret 2, ciphertext 2. Quinn pointed out this does have to be in a specific order. So it does have to be shared secrets first and then all the other crap at the end so that you can count them as fixed info as per 56CR2. So this change sticks. Next. Once Russ is done staring at it. And then finally, inclusion of the trad ciphertext and the trad public key. Calling it trad here because it could be RSA or elliptic curve. We are not including the MLChem CT or the MLChem public key, so that goes to Dan's slide like 3 minutes ago. It is my understanding is it's believed that MLChem doesn't need to bind the CT and the public key externally. It already does it sufficiently well internally. So this construction aligns with X-Wing, and I think it aligns with OpenPGP. Next. That says exactly what I just said. Actually, sorry, hold on. There's an extra sentence there. Go back. So the action paper proves that this is sufficient to achieve the desired binding properties when trad is an ECDH variant. Early reviews by Douglas Stabila, Deirdre Connolly suggest that this should also hold for RSA OAAP, but a proof is needed. A proof is, I think, beyond my personal skill set, so I don't know how we get a proof if we can put a carrot on a stick to get someone to help us with that. I think that is a totally reasonable request, though.
A carrot on a stick.
Yeah. Do we have carrots to tempt academics?
Do we have sticks?
Next slide. Here's another breaking change is we now have specified domain separators. We decided that we weren't going to, actually there's a point here. We intentionally decided not to bring X-Wing's little spaceship ASCII art, even though one of these combinations effectively is X-Wing, and with the rearranged combiner, it really is X-Wing, especially if we drop the counter, it really is X-Wing. We've still decided to keep a different domain separator, and this is a point of debate. We're intentionally breaking binary interop here by having a PKIX specific domain separator instead of the spaceship. And is that a good thing or is that a bad thing? If anyone wants to jump to Mikey
No one
now.
wants to say.
I
No one has
personally
an
think
opinion.
I personally think it's a good thing to have a PKIX specific domain separator. Keep it different from the generic X-Wing, but
Go ahead, Daniel.
So as an implementer, not of crypto, but of this, which is slightly above the crypto, it seems like a bad thing because now you have to just consider many more options. And this actually kind of leads to something else that is somewhat related, which is the various ASM1 encodings of the public key and the private key, not the ciphertext. And this applies to signatures as well. This is all very PKIX specific, and implementations might not want to be doing all this ASM1 stuff if they want more of a general implementation. We don't want, one implementation doesn't want to implement MLChem 768 plus SHA-2 250, or sorry, ECDSA SHA-256 3 times so that they can support composite signatures and something else, OpenPGP, something else, right? It would be nice to be consistent.
I think it'd be awesome if we had a crypto library at the lower layer that was in common.
So we could do that. We could do domain separator is the DAR encoding of the OID for everything except the MLChem, I guess 768 X2F519, and that one we use the X-Wing domain separator and then it's binary compatible. That's possible. We have to move the domain separator to the front, I think, also, but it can be done.
So I guess also, sorry, a related question is, are we still waiting on CFRG work for finalizing this chem combiner work, or are we?
I've got a slide to that point later on. Yes.
Yes, we are.
That's
So all
a
of
discussion point.
So all of this could change anyways.
Correct.
Okay. Well, then I don't have strong comments.
Back to you, Mike.
Okay, next slide. Yeah, I think that slide is important in that it is actually a pretty important interop point, even though it's fairly minor. Okay, the next big change is that we've swapped from RSA Chem to RSA OAAP. This was largely due to a comment on list by Sophie that while RSA Chem is really nice and easy to work with from a design perspective, like 0 crypto libraries on the planet implement it, so not very useful for backwards compatibility. In fact, exactly 0 useful for backwards compatibility. So then the options were PKCS1 or OAAP. And while I suspect PKCS1 encryption is still very common, and the people who have ancient libraries would very much like if LAMPS gave them a staircase to get out of PKCS1, the fact that it's no longer FIPS approved makes it a pretty hard sell for a new standard. So the middle ground then is that we standardize OAAP, and when people come and whine and scream and throw rocks at LAMPS that we didn't give them P1, we say, too bad.
We'll throw you a carrot and a stick.
I'm gonna say you'll throw me at them. Yeah, so this is I think fairly straightforward. This is obviously cryptography that I'm defining here, but how you promote RSA OAAP into a chem needs to be defined. And I think it's straightforward. It's 3 lines of code, but it obviously needs review. So thanks to that list of people at the bottom of the page who within the last 2 weeks have taken a peek at this and given feedback. So that's awesome. Next. Yeah, so DHChem, this has gone through various versions. At one point I submitted a draft to LAMPS called DHChem, and then I dropped it. Yeah, that's it. And then we decided, you know what, let's not have a separate standalone how to use DH in CMS. So this is all part of the making these things less generic. Over the last couple of years, we've made composites less and less generic. So rather than having a nice modularized DHChem, we said, screw it, let's just inline RFC 9180. And so this is a simplified version of 9180. It's simplified because 9180's DHChem in caps binds the public key and binds the ciphertext, which we don't need to do because we're going to be doing that anyways at the hybrid level, at the composite level. So this is simplified only in that it doesn't use the labeled extract with the public key and ciphertext as label. Next. Other miscellaneous changes. Dan suggested that we drop. So in the use in CMS section, we had recommended that the middle security levels get used with an AES 192 wrap. Dan Van Gie suggested we just lift that to 256 for better compatibility with the world.
Next.
Comment from Peter, do you have a better thing to call it? If it's DHChem, if it's Diffie-Hellman turned into a chem, do you have a better name for it? Does 9180 have a monopoly on the phrase DHChem?
9180.
DHChem plus, DHChem star, DHChem minus, yeah, exactly.
DHChem Mike.
Okay, fair enough. We can debate naming on the list if we think that's Chem DH. Oh God. Okay. New OIDs. I'm going to turn off the chat. New OIDs. We have broken interop pretty horribly here, but given that we're not actually aware of any implementations, like 0 people have thus far brought composite chem implementations to the hackathon, we decided to be lazy and not rev the OIDs. Yep, we will definitely start revving the OIDs going forward. I think Carl now has an implementation at the hackathon, and OQS is supposed to have one anytime. So we'll definitely start revving OIDs going forward. Next. Yeah, this I'll fly through. This is other stuff that probably matters less. Since all combinations.
Hey, Mike, we're running out of time.
Yep.
So let's.
Yep. Renamed the document since it's no longer generic and all the combinations are MLChem. It's now called Composite MLChem. I don't know if John mentioned this in his presentation. We did this in both chems and SIGs. We've now got an appendix that unrolls the component SPKIs. So if you need to reconstruct the SPKI, like if you have to hand the public key down to your elliptic curve side and your MLChem side of your library separately, and you need a fully reconstructed elliptic curve SPKI, we decided to have an appendix where we actually give you the full, like fully laid out, possibly even DARE encoded SPKI, so there's no ambiguity about which parameters to choose or whatever. Next. Yeah, chem combiners. So this is Dan sort of brought this up already. Are we waiting for this or not is the open question for the working group. CFRG has recommended, or the design team has recommended, that CFRG start with 3 combinations. So I guess that in theory, 3 of the things on our list of 10 could overlap with CFRG. The other 7 will not. Should we wait for this and then make them binary compatible or not? My vote is not. Let's just go ahead with this, and we'll do a BIS if we need to.
No one seems to be screaming, so take that to the list, firm it.
Okay, I'll have to turn these slides into a big old email. There's a lot of open questions. Okay, next.
I think that one should be separate because a whole bunch of other things will be decided if it's yes or if it's no.
Okay. I don't know who's taking notes. Could you help me with that point? Slide, note taker, slide 17 needs its own mail list discussion. Yeah, so what I've done for now is I've just removed the reference to the CFRG draft, so this doesn't get blocked in a downref situation. Yep, fine. Next. Next. Binding public keys, same question we were discussing with Dan's talk. The open question here that I haven't heard any discussion of, and I'd love if anyone in the room has connections to like smart card vendors or like super embedded lightweight devicey things, is it a fair assumption that like a smart card that's decrypting for you, like maybe connected to SMIME, does that smart card have access to its public key when it's doing a decryption? If we make it mandatory to bind the elliptic curve public key, are we going to run into implementations that say, actually, I don't have access to the public key at decryption time? And I'd love to know one way or another from the kinds of vendors where this matters, if that matters. I am not a smart card vendor. I am a big rack-mounted HSM vendor.
Mike's going to the mic.
Not a Mike St. John's, not a vendor, but it basically just depends upon the applet rather than the smart card. Most of the smart cards tend to, if they're generating stuff on the card, they will keep the public key with it. Obviously, if you've got an elliptic curve, you can recover the public key. Same thing with an RSA key. So yeah, you just need the public modulus from.
This is sort of along the same point Tim made a few minutes ago of if we make this overly prescriptive, then we might be harming backwards compatibility, which is in fact the primary goal here. So I just want to keep that in mind. Okay, next. SHA-3 versus SHA-2. This also came up in Dan's talk. Some people have made some excellent points that SHA-3 may not be available. So for ChemRI, I think we just decided to keep both HKDF SHA-2 and KMAC. If we do the same thing here, then we're about to double the size of the list. Is that desirable? Also, I'll put that on mailing list. Next. Timing. Yeah, the do we wait for CFRG or not question. And my vote is not. Next. We need samples for the appendix, given that no one's implemented this yet, or there's no stable implementations. We don't have stable samples. We still need them. I have some people I can poke offline. Next. We have a long list of other open GitHub issues. Feel free to look at them on GitHub. Next. Thank you.
All right. Any last comments from Mike? Okay.
Quỳnh Đăng, Mike, could you go back to slide 3 or 4 or something like that? Yeah, he is fine. In the function, one of these slides before this one, you said that the KDF is basically SHA-3 256 or SHA-3 5000, something like that, right?
Yep.
I think you're on the right slide, Tim.
That's fine.
Right.
One
yep.
more.
So for the SHA-3 or SHA-2, they have fixed output lengths. So that means you have and it takes only one input, not two. And here we have like something output length.
I'm sorry.
Something. Yeah, that's kind of odd. But if
well, I mean, that's because here I'm calling it a KDF, and then lower down in the document, I concretely instantiate it.
So if the KDF KDF is a function on top of a SHA-3 function, for example,
right,
and the KDF generates more than the output of the SHA-3 function below it, then you might, then you need the output length for your KDF. And then if it's more than that, then you need to have a counter in order to run twice, to make twice or 3 times or something like that, to make more output length for your KDF. And in that case, then the counter is required for each vocation of the hash function inside it.
Yeah, this is just a notation issue. I see your point. I will rename this to SHA-3 -* and then take off the output.
Yeah,
bits for it.
I suspected that was the typo or something, but I just wanted to be clear. Yeah.
Thank you.
Is that a comma or a vertical
It's a truncation. It's saying how much output bits are.
Is the output bits included in under the 800
He will specify.
Yeah, this is just notation. If you look at the document, it's more fully specified that we are not binding the output bit length in the thing, but also it's fixed because we're using SHA-3 256.
Right.
Yep.
Okay. So I think we're done with this presentation. Unless there's more comments, I don't see anyone running to the. Okay, we're now moving to the under consideration for adoption section of the agenda. And the first presenter is Tomofumi.
From here. I failed to post it on the list and have a discussion, so I would like to defer this to the next meeting.
Well, then I was all worried about time, and now I'm not. Because my experience is the composite ones and the under discussion for adoption are the ones that take longest. So that means we're down to the root CA cert rekeying. Julian?
Yeah, I'm here. Yeah,
okay.
Can you hear me?
Yes.
Oh, that's great. Yeah, please, can you show the slides?
Do we have slides?
I believe we do.
What are the names?
You're messing with me.
Yes.
It's the root CA slides.
I'm not seeing it in the list. Oh, there it is. I found it.
Okay.
Got it. They were in a weird order.
Okay, great. Yeah, thank you. Yeah, so this is my presentation. It is a draft about the root CA certificate rekeying in the scenario of post-quantum migration. Thank you. Next slide. Yeah, the basic motivation is that we observed that actually in the RFC 4210, it gives 2 approaches for old entities acquiring the new root CA public key via actually new with new or new with old. Yeah. But our draft would like to propose, or actually some kind of the extension to the RFC 4210, propose a one-way link certificate based solution such that all the entities are transparent to root CA certificate rekeying. Yeah, so such way it is beneficial to scenario where all the entities are not aware of the existence of new root CA certificate or cannot update correspondingly. Yeah, because the main reason is that actually as we giving the example, so in some cases, the certificate lifetime of entity or device can be longer than 10 years. So there is some actually, this is some kind of example. Maybe, some experts do not think so. Yeah, so we are not talking about like some device or entity like the browser, etc. That should have may have some certificate with a very short lifetime and can update easily. It's not that case. we consider something like some entity, yeah, that have the long time of the lifetime, long lifetime, yeah. So logically, the proposed solution does not rely on which cryptography algorithm used to verify the certificate chain. Yeah, so in this way, the proposed solution works in traditional pure PQ and or hybrid PKIs. Okay, next one, please. Yeah, so just to come back a little. So basically, root say certificate rekeying can have just two approaches only. One is the rekeying, yeah, issue a new brand root CA certificate. Yeah, normally this will be better because by this way we can issue a new root CA certificate. Yeah, and also we can update the algorithm or update the key. Yeah, even sometimes you can use a new, totally new algorithm to issue a root CA certificate. But the challenge one is that because the root CA will have an overlap between the old CA certificate and the new CA certificate. So in this case, we need to guarantee it should be a smooth process such that the old entities and the new entities can verify each other's certificate chain. Yeah, another way is called the renewing. Renewing just extends the validity of existing CA certificate. Still use the same key pair, but extended for a longer validity. But this way, the attacker will get some advantage because it has more time. And still, actually, sooner or later, yeah, we still need to issue a brand new CA certificate. Yeah. Okay. Next one. Thank you. Yeah. So here is gave the basic ideas. Yeah. What's the proposal in our draft? Yeah, so basically we will use one link certificate called the new with old. It is just a certificate, but issued by use the old say a private key, yeah, on the new root say a public key. Yeah, in this way it means actually new root say a public key can be introduced to old devices or maybe old entity, yeah, by the old public key, yeah, such that old device can verify a link certificate chain from any new device. Yeah, so the right side gives a diagram, yeah, to illustrate, especially the bottom one. Yeah, uh, it is the typical or most the challenger part. Yeah, it is about a new device B. Yeah, so the diagram gives which kind of the certificate should be stored in the new device. Yeah, so when either case, either the new device communicate a new device or communicate another communicate old device A, so they can send out certificate chain, such that old device or new device can verify the certificate chain. So the main information or main idea used here is that the new with old link certificate, can be used to introduce the new public key to the old device, such that old device can still recover a certificate chain path to verify the new certificate for new device B. Okay, next one, please. So we did some testing, using the OpenSSL. Yeah, actually, in our testing, actually, we have three generations of root CA certificate with different lifetime and considering different combinations between clients and the server. In such case, they should not can verify each other certificate chain. Some case, they should be able to verify each one's. So according to our testing results, so our conclusion, yeah, is actually okay for what is expected that should be. Yeah. Okay. So next one, please. Yeah. Next one. Yeah. Thank you. Okay. Sorry. So the format should looks like not so great, but hopefully it still be readable. So we got quite a lot of comments, yeah, from colleagues, yeah, including Rose, David, Hendrik, and also Michael as well. So some of the comments I not dealt with yet because yeah, thanks a lot for the concrete information. So I'm trying to read the documents. So I hope after a little later I will explain yeah, better way, yeah, more detail, yeah, in the mailing list. I think the main question is that about how our proposal actually is solved, which kind of the question so actually I mentioned here, but maybe it's still not so clear yet. Basically, is that we consider in such a special scenario, we can say it is special. So like the older devices, maybe not designed well, maybe not maintained well, so they cannot do the update, but their lifetime much long, like maybe 10 years or even 15 years long. Yeah, in that case, how we can do uh, transmission about the root public key. Yeah, because those devices may be still expected to work well with the new device. The new device may be already issued with a new certificate chain. Yeah, so all the device in that case, how can still verify uh, certificate chain with new devices? Yeah, so the older device do not expected to do update or cannot do update. Yeah, we just consider this way. Yeah, so we thought it's like a kind of extension of the RFC 4210. Yeah, so this probably is the main point. Yeah. Okay, thank you. Next one. Yeah, so this is about what we are going to do. Maybe give more detail about our testing and check more detail and make a further comparisons suggested by the above experts. So all suggestions, comments, review are welcome. Yeah, thank you.
Go ahead, Scott.
Okay, I'm just trying to understand what the problem you're trying to solve. It looks like the hard problem is how do you distribute the new CA certs so that when the old CA certs expire, they still have good ones. Do you mandate that basically when you get as new for old, that the device record that the new and they validate it, they record the new CA as a something which is as trusted as the old CA cert?
Yeah, okay, Scott. Yeah, so actually here we just suppose actually all the devices not need to get the do not need or cannot get the new with old link certificate. Yeah, they just actually passively just receive the link certificate chain from other device, but they do not update by themselves. Yeah.
If the old CA is still valid, then I don't see how you've solved any sort of security problem, because if the old CA cert is broken because of, let's say, a quantum computer, then the attacker can use basically forge based on that and rely on that and not even mention the new CA cert.
Oh, I see. Yeah, this is not about that question. We are not considering old CA is broken. We just think old CA certificate is still valid. Yeah, but we just introduce another one due to any of reason. Yeah, so like just the continuity of business, but we still need a new CA have been introduced. So in that case, we are considering how new devices with new certificate chain, how they can verify how new device and old device can verify each other's
Okay, so in
leakage.
other words, this is addressing an interoperability problem in case new devices don't have a cert chain from the old CA. Is that correct?
That's right. That's
Okay,
right.
thank
This is
you.
more about compatibility. Yeah. Yeah. Thank you.
Hello, John Gray from
Hi.
Interest. Oh,
Get closer to the mic.
oh, okay. There you go. Yeah, John Gray from Interest. Yeah, I'm just trying to figure out how this is new because supporting like CA link certificates, like moving from RSA to EC and the old CA can still be valid and it will still work and chains will still go to the old one and you can still go to the new one depending what you have in your trust root. So yeah, I guess I'm just not understanding how this is new. Maybe it hasn't been written down before, or maybe CAs just do this already and maybe it hasn't been formalized somewhere, but I thought it was. So I don't know if
Yeah,
that's
yeah, thank you. Jun, yeah, you are right, actually, because after we get a lot of comments, we are also considering whether this is really a new solution or not. Yeah, but basically point is just I mentioned what we are going to do. And also like the new with old link certificate is already interested there. Yeah, so we will check about the detail, make a comparison to say, if this solution is actually already specified or handed some way in the existing document, we will try to check this one. Yeah, yeah, that's a good question. Yeah,
yeah, because I
it's
know.
also the same why it is not so clear for a lot of experts. Yeah,
Yeah, because
yeah,
I know.
maybe we missed some detail there. Yeah, possible.
I think we've supported like this for like 25 years or something in our product. So yeah.
Yeah,
Okay,
yeah,
thanks.
thank you. Yeah, this is the main thing we need to answer in the near future. Yeah, thank you.
Any other questions? Okay, thank you.
Thank you. Thank you, everyone.
So, given the cancellation of a presentation, we are at the end of the agenda. Is there any other business?
Yeah, I was just going to mention, you know, how we're doing all the new PQ algorithms and the use in CMS. So I know we have like the Sphinx Plus one, and we have Chem one. I know there's been a number of people that have been going, I think Daniel and Sean, and I think even Mike and others. And I was talking to Ben about you doing one for MLDSA. I'm just wondering if anyone has an updated status of that. I think some people were going to talk to each other. Obviously, we know that's going to be needed. It's going to come. Someone's going to do it. I guess we just need to figure out who's doing it, just so we don't all end up running, you know, 3 of the same draft.
So if you're interested, just let the chairs know, and we'll be glad to let you know if you're the first. Right?
Yeah, and I guess we'll need one eventually for Falcon and everything that's coming.
Falcon
right?
will. I mean,
I know
this
it's going to come
has
later.
been very clear that Falcon is
Yeah.
coming later.
Yes.
And so we're aiming at the first 3 that they're publishing.
Yeah. Great. Thanks.
Okay. Seeing no other business, thank you very much to the note taker. Thank you, John. We're done. Ask you a question. I want to ask you a question very much away from.
Yes.